We are not receiving data from the report.
There it goes.
Oh.
It's black now. It doesn't say starting soon. That's different.
Oh, I see things. On the live version.
Shift J, or in Firefox you can do Control Shift K, and you'll be presented with this sweet little thing called a debugger. And so you can use it like a calculator. You can do 1 plus 1, 1 plus 2. You can do a string with quotes, basic stuff. You can also do really crazy stuff like document.body.style.background color equals red, if you're so inclined. There we go. So you can basically go to any page and have fun exploring the document object model with JavaScript. But in this lecture, I won't be focusing as much on, be more focusing with this little cursor. So this is like a shell, like a bash. We get the message hello. And if you want to know how to quit, Control D. And is this will get printed. It's just like how we JS. You can use any editor you want to create this program. So if you do console.log, open paren, you type node hello.js, and you should see a message, boop, or whatever you put. Right? So to demonstrate a bit what's going on here, when we do console.log, this is called a function call. So it's like for mathematics, how you might have a sine function or a cosine function. In JavaScript, there's a bunch of built-in functions, just like in math, where you can do things like print to the screen or all kinds of other stuff. And console log will automatically insert a new line for us too. So there's another way to print a string without a new line that's specific to Node. If you care, it's process.stdout.write. We'll get a little bit more into later what those dots mean, but for now you can just type them. And so if I run this program, it prints beep boop, but it doesn't put a new line, so our terminal is just stuck there. So fun. A few more things. So when we do the string beep boop with quotes around it, that chunk of information is called a string. A string is just a sequence of characters, like a piece of text. We might also call that value an argument, because a function takes certain values, certain parameters, one after another, and those are all called arguments, just like on the command line. But in JavaScript, we separate arguments with commas, not spaces. This is the main difference. You can also use double quotes if you want for a string. And you might also hear arguments referred to as parameters or whatever else. So it's just interchangeable, largely interchangeable jargon. So another fun thing we can do with JavaScript is do multiple things, like a cookbook or recipe. So if we take our previous program that printed console log beep boop, we can print another message after it just by adding a new line. So we can add a message whatever, we can add a message cool beans. Each of these messages will be printed one after another. So if we close our program and run it again, we see 3 messages. You can also put semicolons if you want, that's a popular style. You don't have to, it works either way, so just do whatever you want. Same program. These lines are called statements. Basically everything that's separated by a semicolon or a new line, for the most part. That's not strictly true, but everything that's here, like each one of these things, is called a statement. So a statement is like a command. It's like, computer, do this thing. And then the computer goes and does it. You hope. Or it should explode, whatever. Okay, so let's do some more things. We can define variables. Variables are values that we want to substitute for the real thing. So instead of having just these strings defined inline, like what if we had the same value of 444 variable n up top, then we can substitute whatever value we wanted to replace right there. So this will print 444. You can declare as many variables as you want, like this. It's also common to see variables declared like this. And you can even include a new line if you want. Sometimes people like to indent, sometimes not. So it's pretty free form. You can do whatever you like here. You can put new lines or not. You can put them on different lines if you want with a separate var statement, or you don't have to. All of those are completely valid. And you can know that because the program still runs and still does the right thing. Another fun thing you can do is use variables and other things to make expressions. So we have a few variables now, so we can do things like n times y plus x times z. And this expression is going to be evaluated. So I'll talk a little bit more on that in just a moment. But those are the basics of how JavaScript works. And of course, you can do all of this var a equals 10. And then in the node REPL, when you type node, you can see that way. That's a fun way to sort of prototype pieces. So with a calculator, because we can be the third indexing by 2. So we do that, we get 7. So you can also save any of these nested properties to a new variable if you want. So if we want a new handle on the z variable, but we want to call it something different, like zoology, then we can just do nested.z, and now we can just type zoology instead of typing nested.z all the time. So .cabbage 2. Still prints 7. Great. So that's how nested data structures work. One thing I did not mention about arrays is that the destructive updates and the assignments also work with those when you take an array. So a fun thing we can do maybe is that when we modify zoology.cabbage2 times equals 1,000, and now we print out all of nested, we see that, hey, now cabbage at index 2 is equal to 7,000. This is because when we made a copy, this is called a reference. So we didn't actually copy all of the data, we just saved kind of a pointer or reference to that spot. So whenever we modify zoology, we also modify nested. And whenever we modify nested, we also modify zoology because they sort of point to the same place. So that's just something to keep in mind as you're building stuff with nested data structures. So far.
I'm still kind of lost on how it changes everything. That last thing that you put in. Yeah, that.
Okay.
Can you explain that again one more time? Why it changes nested too?
Yes. So this changes both nested and zoology because when we take a record like this, so zoology equals nested.z, you can think of this in terms of that substitution principle, where this is basically the same as value function that we typed inline right here. We crammed it all into that variable. So it's almost like if we didn't have that variable at all, and we just did the variable ourselves right in here. So that does the same thing for us. But it's a little bit nicer, I think, to have a more general function that accepts another parameter to the operation. So these have all done the same thing, all of these kinds of transformations. Okay, so that map function that we just wrote is actually built into JavaScript, which is very handy. So we can delete all of this code and instead rewrite it like this. So it's actually a property of arrays. So if you do .map, it's the same thing. So luckily, we don't have to write that code ever because it already exists in JavaScript. So if we run this program, it's the same, right? And if you're on the REPL, it's pretty fun to just play around with different things that you can do with maps. So like return x times 2. There's also there are a bunch of functions like this that are. Another one is called for each. This one, instead of generating a return value, just loops over all of the value for loop and creating a counter variable and all of that stuff. So with for each, we can just do, instead of doing a console log, if we have an array for each, and then maybe we'll print out x equals each value. So this is a very compact way to loop over elements in an array. There we go, 427. If we wanted to loop over something else instead, another common thing you'll see is if we had an object, right? Like 4 or 3, 4, 2. We can loop over the keys of the object using, from before, object.keys, capital O object. And then if we loop over the keys, so the first parameter that we get will be the string key name, and we can then reference the value by using obj square brackets. Instead of that state being saved for us, implicit variables onto a special keyword called this, this. So this is an object, and we can just assign properties. So we probably want to save the number of teachers and the number of students. Some other things that we'll need to do is we'll need to make different methods, right? So we'll need a method like before for adding, and we won't actually have to implement getting, because when we do this.teachers and this.students, that will be available to the outside. So says to people, hey, don't touch that. JavaScript is not a language that tries to force you to do anything in particular.
There's no way of keeping it from getting around.
No. So if we want to implement some of the methods we had from last time, we could implement, okay, I'll implement add teachers. This would be a very simple function. We'll just implement them all. So teachers get plus equals x, and we can make another method called get teachers that just returns the value of this.teachers. Did you have a question, Terry?
Yeah, do you want to explain prototype?
Right, so what prototype does is everything that you assign onto the prototype of the function will get put on the object. So it'll
So like if you want to make like a private school and
not to any school. It's a bit complicated actually. You have to use some modules basically. Best example. It's also not something that you really want to do very much. Aside from event emitters and node and streams, I pretty much never do that because it's often better to just not do that. I don't know why.
Just doesn't work sometimes.
Yeah, it just doesn't. It doesn't tend to work out very well.
so it's just not really object oriented, like friendly, I guess.
I think that inheritance is just usually not what you want. What you can is that let's make some semblance of
I have
sense.
one more question.
Yeah.
So if you could go up to where you do the dissing,
Yeah.
so didn't
X isn't defined. That wouldn't do anything. What? Yeah. So there's no X here. There's just no X in that scope, unless you defined it. Okay. Maybe something. Maybe you'll remember some of it. So there's a bunch of built-in methods. Let's just play around with them. So one of them that's fun is if you have a string, you can always do .to uppercase, or also .to lowercase if you were to save a very leet, and we do n.toString, right, we get leet as a string. But if we pass in a base value, you get toString in binary. You get leet in binary, which is what that is. Or you can do in hex, a different value. There we go. Do some bit twiddling. There's a lot of reasons. You need a matrix. New index here. Some fun ones are like there's a built-in math object, but if you just type math, it gives you this garbage, right? It says, oh, it's an empty object, but it's lying. If you hit up in there, any JavaScript.
Also inside of the browser. I didn't notice that.
Yeah.
Okay.
So you can do math stuff, right? Types. So the built-in types with a string, give it 0, then you get back false. So there's a lot of fun stuff to play with there. So right. So this way to out of this string. The string is separated on colons. So if you take math.log, by default in JavaScript, this is base E, that weird transcendental number. So if we want to convert into base 2, we can just divide by math.log of 2. So it will take 11 bits to represent this number. And we can confirm that by converting that to binary and looking at the length, which is 11. Cool trick. You could also do that with a different base. So if we take log 256, that should be the number of bytes, which is greater than 1. So we'll need 2 bytes to store that number on our system, because a byte data passed. Date.now. If you want some homework, internet friend Seth school.io. If you have done some learning Node and it's a great little introductory to some more concepts, just some basics of JavaScript, basic types. Covered a lot of the same stuff we cover here. So if you want this material from like a different that I've got.